Okay, now we've got a little bit different of a task at our hands. I want to show you the whole big picture that takes place in this entire kind of thylakoid membrane ensemble. And to do so, I can't get it all on the chalkboard. So I'm going to take a big fat marker and I'm going to draw this important figure. You're going to draw it as well. And then after it's all drawn, I'll be able to get some colored markers out and put in the details so we can totally understand the process. Here we have it. We're going to start here with, let's see, some thylakoid membrane. Then I'm going to draw a photosystem here. Kind of a cartoon-like photosystem in the middle. Going to identify these good parts. I'm going to go ahead and draw some chlorophylls here. And I'm going to draw those special chlorophylls right here. Then we'll continue with this process. And in this particular case, we're going to stick a big Q. And embed that in membrane. All right. Now we've got something else to draw that you haven't heard about yet. Okay. And another photosystem. There's that. Draw just like I did before. Reaction center chlorophylls. Acceptor. Little chubs. Okay. We got a little bit more to squeeze in here. So now we want to take our thylakoid membrane around and start to bend it. That will be good. Okay, that's cool. And then let's construct our lovely and elaborate ATP synthase. Okay. All right. There's that. And a little bit more membrane just to kind of finish it off. Go ahead and throw in some of those tails. Okay, wow, that's great. Yay. So I can see the whole thing on the board. Let's put some kind of other cues here as to where we are. So this is the thylakoid membrane. Therefore, as always, this is stroma. This is therefore thylakoid space. So that's where we are. And let's get a couple of other very important features here. So way up here, let's see. I'm hoping that you can see that up there. Well, it's looking pretty tight. Let's see. Bear with me. Okay. So way up here then, we need to put our happy sun. And the sun, of course, is sending its photons down, ultimately, of course, to start that beautiful process, which we'll identify in a minute. We have to label this part. This is going to be our PS2. We've got to stick something down here. This is PC, plastoquinone, plastocyanin, and then up here we need to place FD, ferrodoxin. I think it's giving you an idea of where these are located spatially. Okay, we need to name this as the B6F complex. We need to name this as PS1. We need to, of course, name this fabulous guy over here as ATP synthase. Alright. And I guess we need to imply that, the sun is sending its rays over here as well, right? So that is our big picture. What I want to do now, I'm going to still stay with this black pen, and I'm going to show the energy. Actually, I might even change colors here. I only have Sharpie wise, I only have red and blue, but I have these other pens that might work for me. So how about this? I wonder what would happen if we, yeah man, this is the chalkboard as well. So now we got a good kind of solar energy color for us, right? That's awesome. And because of that, we can kind of change into this energy transfer process. So there's the solar energy, and then we're going to draw, as we did before, these energy transfer steps that ultimately excite and release an electron. And it's actually here where we're going to pick up with red. So when this energy is transferred, we're going to take an electron and send it up here. This, by the way, is PQ, and I'll draw the next arrow. These arrows are going to be very important, these red arrows. So I want you to make sure that you're capable of identifying. We're going to draw several of these arrows to show the whole process. So everybody have that one. We're going to draw another step now, and that step is going to roll from here And of course that's this guy, PQ. I'll go right through it. And put my arrowhead there. So there's a really defined kind of step. Okay, we'll identify those steps as I mentioned. Then the next step is going to be all the way from here right into that reaction center chlorophyll. And our next arrow, a little short one that goes here. And I'll actually stick an electron here. That's that. 1, 2, 3, 4 arrows. A fifth arrow. I gotta draw one more thing here, by the way, in black. Gotta draw this guy sitting up here. It's a big Hershey's Kiss up here. This thing is going to be called N. You know this name. This is NADP reductase. Okay, NADP reductase. So there's all of our parts. Let's get back to the red, make another arrow. So we're going to go to FD here. And all the way to NADP reductase. Excellent. And then lastly, I'm going to add some things to this process now, very important for NADP reductase. So here we will have NADP plus. That's going to be part of the story. We're also going to have here coming in H plus, and that's very important. And those things will come together with the electrons that we get out of this deal. So this is our last journey. And give us NADPH. Put together a little bit there. If you've caught up, you can revisit this as well. Reduction, reductase. So bring on an electron. That electron has reduced NADP plus to NADPH. Wow, very cool. So there is the lay of the land. I've got one more thing to do though, way upstream. We have to add something here. Another little Hershey's Kiss for our cartoon, and show that we're going to start with H2O, and that H2O is going to be split into 1/2 of a molecule of O2, and we're going to get 2 H plus ions, and then very importantly, our first process. Our first journey of an electron. So everything here is electron journeys. Okay. So I'm just going to let that thing stay on the screen for a little bit so you guys can finalize your drawing. But of course you can pause it and get all the details. So just a few seconds. But go ahead and pause that and get it exactly like that in your notes, because now the fun starts. Okay. So now what we're going to do is label each one of these processes. This is number 1. This one here is number 2. Then this one here is number 3. This one here is number 4. This one here is number 5. This one here, number 6. This final one here, number 7. Okay. So now what we're going to do is we're going to identify every one of these things. I'm going to call these things in red electron journeys. So what we need to do is make a table below this. We're going to look at every electron journey. We're going to look at the work done, and we're going to look at its impact on H+ concentration. Those 3 things. This puts it all together. This is a way for us to see the whole process and understand it. Okay. Okay. So I moved that down a little bit. You can see what's up there because it's right in front of you on your notes. We want to create a table now. And so this table is going to have 3 columns. So the first column is going to be electron journeys. And therefore I mean from 1 through 7. The next one is going to be the work done associated with that journey. And the last one is going to be the concentration of H+. Remember that brackets indicate concentration. The concentration of H+ in the thylakoid space relevant to the concentration of H+ in the stroma. All right. So now let's put our journeys down. Here's number 1, 2, 3, 4, 5, 6, and 7. So those are our 7 journeys. We're going to fill these across this way. I'm going to double check and make sure that it's in view. Oh, it certainly is. Beautiful. So I'm going to run some simple lines here to kind of give some better structure to the table. Okay, there's our table. All right. So I'm going to lay these things out. I'm actually going to start right here with number 2 where we started to give some flow to this. So we have the sun, we have solar energy, we have transfer of energy, and ultimately we're going to lose an electron from this reaction center chlorophyll. Oh, actually, I should identify that this is P680 and this is P700. Real quick, before I get to this journey, why is PS2 the first one and PS1 the second one? The reason for that is discovery. PS1 was the first described by science, PS2 followed, so it's really an historical kind of record rather than a system that actually makes sense in terms of the flow of the process. So here we go, PS2, P680. I'm going to say here, therefore, that we have excitation / release, and that's the important part, from P680 of PS2. That's that journey. That arrow is described by that. Continuing on for number 3, we have pickup by PQ. I just screwed that up, but that's okay. PQ and carry to the B6F complex. So that's what this one is. Pick it up, this is PQ, and take it to B6F. Then for number 4, we're going to have pickup by PC, and we're going to have a carry to P700 for, this is exciting, what I call hole filling. I'll put a squiggly line under that. Here's the deal, and you can take a few notes on this right now. I would stick this maybe down on a little scratch pad next to your big piece of art here. Hole filling, what I'm talking about is that this reaction center here, with these reaction center chlorophylls, when one of these reaction center chlorophylls loses an electron, it leaves a space for an electron that has to be filled. So it leaves a hole for an electron, and hole filling is what we're talking about when an electron transported by PC is used to fill the hole in this reaction center chlorophyll, which of course in PS1 is a P700. We're going to see hole filling back here. That'll actually be our first step. But let's continue with what we're doing. So number 5, we're going to have excitation / release from P700 of PS1. So that's that journey right here. It's number 5. Number 6 is going to be pick up by FD and carry to NADP reductase. So it takes it to NADP reductase. The seventh journey is that the electron is going to be used by NADP reductase to reduce NAD plus to NADPH. Wow, that is crazy. So now we're here. Let's go back to fill this hole that we made. So number one is, importantly, in parentheses, from the splitting of water. And it's going to be for hole filling in P680. So there we have our journeys, all of them. So again, pause your recording, pause the video player. Make sure that you have this all super tight, and then we'll identify what happens in these other parts. Okay, some work. I'm going to show you that what we're going to do here is we're going to pump H+. We're going to pump H+ down here. So this actually is work. So again, this particular part here for number 3, where we've carried it here, this is going to be the driving energy. This electron is going to drive this pump, this pumping phenomenon, and we're therefore going to identify this as H+. This is work. H+ is pumped. H+ is pumped from the stroma to the thylakoid space. So there's that bit of work. Down here, we've got some work for number 7. We're going to have H+. H+ is going to be, or excuse me, not H+. We're going to use the electron energy, or excuse me, I got off track. H+, plus the electrons, H+ plus electrons to make NADPH. All right. The next part of our story is to identify what happens over here in regarding H+ concentration. So let's take a look at H+ concentration. we've got H plus here. We've got H plus here. And we actually have H plus here. So we have these three places where H plus do their thing. I've got work to do over here, by the way. These H pluses, actually let's finish this. So we're going to have these H pluses This H plus is driving this bus, and then we know that this process brings this about. ADP plus PI going to form ATP. And one last final, you're not going to be able to see that very well. I'm going to add orange to it. Boom. Okay. So let's take a look at then what is happening to the concentration of this area relevant to this area. This is the thylakoid space. This is the stroma. We're going to look at what happens with this concentration relevant to that concentration, and here's how it works. For step number 1, we're generating it in the thylakoid space. That obviously increases. And then we actually have to go to step 3. We're pumping it there. So that's an increase. And then finally, if we remove it from the stroma, then we're increasing it in the thylakoid space relevant to the stroma. So finally, we put that down. And we have our deal. And I guess it's saying in parentheses here, by decreasing H plus concentration in the stroma. All right. Wow. Okay. So the last thing that we need to do with this whole story is kind of just summarize what we get out of the deal. So I still have enough room right down here. So we got ATP we have ATP and we have NADPH. Both of these things are in the stroma. And what's going to happen with these is the next part of our story. We've got some synthesizing to do, photosynthesis. And ATP and NADPH are in the stroma, and the process here is that these guys are going to the Calvin cycle. And as long as you can see that on the bottom, we are done with this beautiful, beautiful section.